Hey guys, so I'm recording this video because I realized at some point last week that I had messed up in a couple of sessions working on this problem. So I just decided I would make a video and correct it and send it out with the rest of my review. Okay, so this is in chapter 9, gas laws. This is working with the ideal gas law equation. So that's PV equals nRT. So number 27 on my handout 13 says, what mass of sodium azide decomposes to fill a 24.5 liter airbag with nitrogen gas at 295 Kelvin and 1.25 atmospheres? So to start working this, we first have to sort of dissect this question. So ultimately, we want to get into mass, so grams of sodium azide. But if you'll notice in the wording of this problem, it puts us in nitrogen gas. So that's what we're solving for, and that's kind of where I messed up earlier. So right now we have enough information to go ahead and solve for nitrogen gas. So taking our equation of PV equals nRT, we're given our pressure of 1.25 atmospheres. A volume of 24.5. We're looking for a mass, and remember that mass in grams is really code for moles. I don't know why I put air quotations on moles, but mass in grams is really code for moles in chemistry. R is our ideal gas law constant, that's 0.08206. Our temperature is 295 Kelvin. Remember that when you're working with pressure and temperature, your temperature has to be Kelvin, your pressure has to be atmospheres, because that's just how. And I kind of want to revisit the wording of this problem in case you're still confused as to why are we solving for nitrogen gas right now. So we're talking about decomposition. We're talking about the end product. If you'll notice, this wording is saying, okay, you filled up this 24.5 liter airbag at this temperature with this pressure, this gas. Also, sodium azide is not a gas. So that's a big part of this. And I don't know the formula for sodium azide off the top of my head, but looking at the problem, or I'm sorry, the equation that this problem gives us, I can pick out 2Na solid, that's just sodium. I can pick out N2 gas, that's nitrogen gas. NaN3, I don't know what that is, so that must be my sodium azide. And another part of that is knowing what a decomposition reaction looks like. That's going from one compound decomposing into the individual elements in that compound. So our end product is nitrogen gas, but I want to know how much reactant do I need to put in there? If you have Miss Adams, you've probably heard her talk about this problem. She really likes it. It will 100% be on your exam. You will see something about sodium azide on your exam. And that's because this is actually what goes into your airbags. And if they mess this up, they put in too much, it could be the reason that somebody dies. So it's a very particular thing, and that's why she likes it, and it shows a practical application of chemistry. Okay, back to the problem. So I encourage you to pause the video right now and try and work through this. And then watch my work, compare it with yours, see if your answer is right or wrong, and determine maybe where something went wrong if you do get the wrong answer. So what I would start off by doing is I'm going to try and get this n on its own algebraically. So I'm going to divide by 0.08206 times 295. And that's going to cancel these out. Now what I'm going to do alongside you is plug this in my calculator. Personally, I'm really bad about what it is calculators. a lot of people can type all of this into their calculator and get the right answer. If you've discovered that you're a person that can't do that, don't try and put it all in at once. Take it step by step. So the way that I type this into my calculator is I do 1.25 times 24.5 equals, and then whatever that is, I divide by 0.08206, and then equals, and then I divide that by 295. If that doesn't make sense to you, don't worry about it. Do what makes sense to you. This works out mathematically. It makes sense to me, and so that's why I use it, and it's what helps me get the right answers. So now I've ended up with, looking at our significant figures, I need 3. So I end up with 1.27 moles is equal to N. Remember that this is of nitrogen gas. And I know that this is moles because N always has to be in moles. Okay, so now I have my moles of nitrogen gas. I need to be in sodium azide. Think about what in this problem can I apply these moles to in order to get into sodium azide? So go ahead and just take a moment, pause the video if you need to, think about it. The answer, this kind of goes back to chapter 4, stoichiometry, using these balanced equations to relate two things together. So I'm going to switch colors to red for the second part of this problem. So I know that I have 1.27 moles of N2 gas. And referring to my balanced equation, I have 3 moles of N2. And that is in relation to 2 moles of my sodium azide, Na. And so I can get to moles here. If you prefer to go to moles here and then another thing like this to get into grams, that's totally fine. I prefer to do it all in one go. So I'm going to come down here. I'm going to put 1 mole sodium azide. And I actually don't have my table, so I'm going to pause this video, pause the recording, grab that, and then we'll continue. Okay, so now I have my periodic table. I have 1 sodium. Looking at my periodic table, so I'm recording this based on Adams's, what she prefers to go by, just because that's who I had, that's who I was an SI for, that's who most of my clients are for. So that's just what I'm very attuned to. So Adams likes to go to 2 decimal places. So sodium would be 22.99. And then I'm going to do 3 nitrogens. Nitrogen is 14.01. So I'm actually going to do 14.01 times 3, and then I'm going to add the 22.99 to that. And I get 65.02 grams of sodium azide as the molar mass. Our moles of nitrogen cancel. So now you're going to calculator again. If putting everything all in at once just isn't working for you, don't try and force it. I spent a really long time doing math, but a really long time getting questions wrong because I kept doing that. So the way that I would type this into my calculator personally is I would go 1.27 times 2 and then enter or equals. I have a Casio, so mine is execute. And then I'll take that answer times 65.02. And then I'll take that divided by 3. And I get, based on this last portion, pause the video to answer this after I ask this. How many significant figures should your answer have? So if you're in Martinez's class, he's definitely a stickler about significant figures. He's very lab-based. And in the real world lab application of chemistry, significant figures is very important. And if you're in Adams's class, you will definitely take off partial points. So this takes 3 significant figures because of this. Whenever you're determining significant figures, you do not consider conversion factors such as this or this 1 mole. So we end up with 55.1 grams sodium azide, and that would be your final answer. So if you've watched this through and you've watched it through again and you still don't understand where these things are coming from, just send me an email, message me through EAB, whatever you need to do to reach me, and I'll do my best to try and help you out with this. And other than that, I hope you guys do well on your exams, and I hope this helped explain for anyone that I may have messed this up for.